Alright, so here's my CNC router I've been working on. There is a big difference from the last video I did, maybe a month or two back now. Reason for is the camera that I had before really sucked. And the battery life, it just didn't last but 15 minutes with a couple of AAA batteries, and it just sucked them down like crazy. Now, always make sure they're clear first. Now right here, as I'm going to have to pick you up and move you so you can see. Alright, so we'll slide over this way here. You'll get to see the X, Y, and Z axes. Alright, you got your 270 ounce stepper motors. One here for your Z-axis, Y-axis, and X-axis. Now, I may have them plugged in wrong, but that's about the ballpark of it right now. Now this back plate is going to have to get modified so I can stick my my router on there. It's just your normal everyday Ryobi router. Let's see. Now I built a custom box to house the computer and stuff in there. And nothing special here. You got your power source, and you got your XYZ and your this one here has nothing plugged into it, but that is for, say, if I had a motor, well, it would power either a 4th axis or a brain fart. Hold on. The spindle head if I didn't use my router. Move out of the way here so you can get some better sight. This socket right here goes to the user interface, which I do not have quite yet. Right here is your parallel port for the computer that I have upstairs. It is your old school printer cable, really. And you've got your power cable, and then it also doubles back around to right there in the corner. Now, please excuse the light. We had a lightning strike just outside the house the other day and fried one or more of the bulbs here in the basement. So, I got my string here for the overhead light just over this. Alright, let's see. Now, the 80-20 aluminum that I spoke of is this right here. It uses these nuts here, known as T-nuts. They're supposed to be mounted with the little protrusion there through the top, or on the bottom, so it slides in as I knock it over, right like so. I slide that sucker in there, and I can use a nut or bolt. I've been using machine cap screws. Going to find one right here. So it's threaded for a 1/4 inch by 20 threads per inch. So known in layman's terms, 1/4 20. Oh, that's one of the ones that has to be re-threaded. So you got it right here, like so. You'll stick the cap screw here through whatever material it is you are working with. Quite often enough, though, it is easier to do with the stuff already together. Set this down here just to make it a little easier. I am not left-hand dominant, that is for sure. See, as it screws in, like so. And then you screw it down in. I'm trying to hit a button here on the screen. Give me a second. There we go. Move my muzzle loader. That is a reproduction of an 1853 three-band Enfield, standard issue to the United States soldiers of the Civil War. British-made import, two standard types of rifles that were issued. Standard types, not uncommon like the Sharps rifle, which is my favorite. First breech loading paper cartridge before they started coming out with. Anyways, I'm rambling on about something else. Alright, so you have it here, and it'll lock it right down, right in place. You can come in with I come along with a 1/4-20 tap, and I tap these holes out when I need to, because as you see, this end here is plugged, holding the sucker right together. I'll actually move the entire rig before that comes apart. I got angle iron for the legs here. There's Garrus. Garrus, hey Gear Bear. Named him after Garrus from Mass Effect. Nose. Alright. Now, custom mounted brackets for the back here. And it is a free turning there bearing, sealed bearing. And what I did was I took I'm going to use this here as an example. I took this here and trimmed out the corner of each piece here, smoothed it out so I could tap that in. And it's just around a 1/2 inch. I'm trying to remember now, it's been a while since I've done that. And because doing this piecemeal, it's taken me about 2 years now to do the project. Now, see, sometimes I'll use grease, or grease will end up on there somehow. So I have markings all over it from when I'm doing miscellaneous projects. And this is a Acme thread that I'm using for all the drive. It is a 1/2 inch diameter by 10 threads per inch. So if you take an inch and measure and count out each thread, you'll have 10 of them. Custom bracket mounting bracket or couplings that I made. And as far as I know, they work really well. I ordered the shafting from a gentleman off eBay, but I didn't quite do it the proper way, and because it was custom sizes I wanted to order. A couple of the longer access here that I have are quite not, really not that straight. So only time will tell if I have to replace them or not. Well, that would be a huge waste. I made custom brackets for the anti-backlash. Backlash is when you're rotating one direction and you stop and go the other. Like so, if you're going this way, you stop and you got to go back the other. There's going to be travel between the two, so it'll stop, and as this rotates back around and the new thread comes back through to engage, it's going to have a gap, and sometimes it could rotate. I've seen extremes up to a couple of rotations on some, but nothing like this. But I made my own anti-backlash with, I took the 80/20 1-inch squares and I cut out a chunk halfway through each side. I took a square nut for, threaded for the 1/2 10 Acme. Put a high tension spring in here, turned it down 1 or 2 and slid it in. And it keeps it from having any backlash, and it also keeps from, like say you're cutting something hard and it'll start to bounce. Hopefully that'll help keep my bits from breaking off. The hole you see here, that was from a previous attempt for my bearings here. That was a mistake, but I was still able to reuse them. I try to recycle as much as possible. Hey look, you can see my reflection. Guess I got a good polish on that. Now the next step is I have a new interface coming in that will replace pretty much this whole electronics box. So I'll use that box to do something else with. Now I'm going to have to order some new, these are called pillow blocks. So you'd have them here, here. These are the bearings that ride on the shaft. So I had to retap all of these. And these here, I'm going to want to sink these in a little bit. And then I want to put a angle plate right across the bottom here. That way I can set my router on there. Run into my shop here, which is a disaster still. This here is a lathe made, oh, if I didn't let it rust over on the edge here. Right here it says manufactured, gives you the part number, and it was manufactured July 25th, 1863, just after the Battle of Gettysburg. Alright. The gentleman who sold that to me, we didn't realize how old it was, but he didn't want to sell it to somebody that was going to scrap it. So I started rebuilding it. Alright, drill press, full-size email, working on my forge here. This is another lathe here. This is something I'm fixing the bearing surfaces here. I'm doing some hand scraping. I can show you that a little later on. Bandsaw. Thank you to my brother's father-in-law. May he rest in peace. He is definitely missed, Dwight. Alright, let's see here. What am I looking for? I got myself sidetracked. Ah, yes. Yep. Alright. You see here, you're also going to get to see the progress of my shop getting cleaned up, fixed up. Alright, so right here you have your general purpose Ryobi, right? Yep. Oh, no, rigid. Okay, rigid. Let's get the cord off of here. Alright, so you have your general rigid router. Now, I need to take these sleeve off. And you know what? Let me go put you back on the tripod without knocking everything over. And I'll explain more. Alright. Take the back off. So there's several ways I can do this. Right, you have the bracket here that houses your router. See, it slides right in. No big deal. Now, I can make a bracket that'll take this bottom piece off, stick it on there, bolt it down, and then slide that in there, but it'll give me a little wobble. Or what I can do instead is, pull the cord and almost hit my dog with it, and he now looks confused. Now, what I can do with this is I can make a special plate that'll attach to this right straight across, and it'll clamp it right around here with a bolt that goes across, holds it in place, and as it cuts and does its thing, it'll hold it real rigid like. And that's probably what I'm going to do. I'm going to have to measure the widest part right here for the around the circumference, so I know how wide this piece needs to be. So I get the circle that I need. Then I'm going to have to cut it in half, stick it on here, and then bolt it right across the center just to pinch it in half. Now I don't want to cut the whole thing right straight down the middle and go, oops, now I have two pieces. It's going to be one piece with a slice straight down the center that doesn't go all the way back. Slide this in, bolt it, and we should be good to go. You know what? If you give me a minute, I will set this up, and then I will take you along with the ride. How's that?